Hey guys, welcome to week 2. Hope you had a good weekend. I'm just going to record maybe like a 15-minute video right now. I'm trying to go over a couple of the topics that we had problems with last week and go over the stuff we're going to do this week for our new mission. Alright, so hang tight. We're going to get started and I'll do the best I can. Okay? So last week was just a big review, looking over what questions you guys got wrong the most. Let's just go over a couple things. Alright? So if you remember, in terms of number of tiles equals 1 plus 3p, right? The multiplying, the 3p, that's our multiplier. That's what's going to change and determine how fast something's either going to change or not change, right? And the addition right here, that's our constant. That's where we're going to start. That doesn't really affect how fast anything changes. So in this example, we're going to start at 1. And then for each position number, 1, 2, 3, 4, 5, it's going to go up by 3. So let's try to find the graph that matches. So if I put 0 in for p, 3 times 0 is 0, plus 1 is 1. So at 0, it should be 1. Yep, that matches. At 1, I'll put that in. 3 times 1 is 3, plus 4 is 4. At 1, it should be 4. Yep. If I put 2 in, 2 times 3 is 6, plus 1 is 7. At 2, it should be 7. It is. So this graph matches this equation up here. This one doesn't because it doesn't start at 1. This one doesn't start at 1 either, and neither does this one. So none of those could be the right answer. So it's important to remember, whatever we're adding, that's our constant. That's what stays the same. That's our initial value, our starting point. The m, whatever we're multiplying by, that's the part that changes. The growing part, the rate of change. As it increases, the line will get steeper on the graph. As it decreases, the line will get less steep. Right? So multiplier, what changes? Constant, what stays the same. So let's do that for one more example together. Lamb is going to the fair and it costs $15 to get in and $5 per ride ticket. Which graph represents this situation? So it costs $15 to get in. So it's going to start at 15. Does that start at 15? Yes, it does. Does that one? No, it doesn't. Does this one? No, it doesn't. Does this one? No, it doesn't. So without even looking at any other thing, you know it's going to be this one right away because not the other graphs start at 15. But let's just continue. So at 1 ride ticket, it's going to be 1 times 5, right? So 5 times 1 is 5, plus 15 is 20. So if you go to the fair and get 1 ride ticket, it should cost you $20. Does it? Yes, it does. It should be $5 extra per ticket. So if I want 2 tickets, it should be $25. Yes, it is. 3 tickets should be $30. Yep. 4 should be $35. Yep. 5 should be $40. Yep. So this graph matches. Starting point is 15. That's our constant. And it goes up by $5 per ride ticket. Right? That's our multiplier. So if we're putting it back in this equation right here, y would be total cost of the fare. M would be 5 because it's $5 per ride ticket. X would be the amount of ride tickets you buy. And B would be 15 because that's how much it costs to get into the fair, right? $15 to get into the fair. That's our constant, our starting point. However many tickets we get, we put here. We times it by 5 because it's $5 per ticket. That's our multiplier. And that's going to give us our total cost for the fair. So if we charge $5 and we go on 3 rides, that's $15 on rides, plus $15 on our ticket to get in. 15 plus 15 is $30. So if I want to spend $30, I can go to the fair and I can ride 3 rides. That's how that would work. Any questions about that? Let me know. We can talk about it one-on-one. This one's more of an equation form, right? So Belinda's renting a moped to ride around for the day on her vacation. The moped costs $30 to rent plus an hourly fee of $5. What is an equation you can write that shows the cost, right? So the cost That's the same as our y, right? Our y equals whatever. That's our c. Cost. How much? Well, it's going to be $30 to rent. So no matter what, we're going to start with 30. So it's either going to be this one or this one, right? Because the 30 is separate. And then how much does it cost? Well, it's $5 per hour to rent the bike on top of the normal cost to buy it, right? So it's $30 plus 5 times how many hours you'd ride it. 5's our multiplier, 30's our constant. This is our right answer. $30 to rent it plus $5 per hour. So if we wrote it for 10 hours, it'd be 5 times 10 is 50 plus 30, $80 total it would cost us to get that moped and ride it for 10 hours, right? That's how that works. Constant multiplier. These ones were the same thing, but instead of having to look at it and find an equation, we have to look at it and match it to a table of values. So let's do one of these together real quick. The following table shows the cost of a large pizza. Number of toppings, 0. So just cheese, it costs you $10. If you want to get cheese and pepperoni, it's $11. Cheese, pepperoni, and bacon, $12. Cheese, pepperoni, bacon, mushroom, $13. Right? An extra $1 per every topping you get on it. So that's what it's asking us to kind of decide. What is this table saying? Well, it's saying a large pizza costs $10 plus $1 per topping. $1 would be our multiplier times the amount of toppings, and $10 would be our constant, right? That's not going to change, that 10. What's going to change is the amount of toppings you get on the pizza. So 1 is our multiplier. Per topping will be our x value that we're timesing the multiplier by. This would be our constant, where we start, and then y would be our total cost of the pizza, right? So total cost of pizza equals 1 times the amount of toppings plus 10, if you wanted to make it into an equation. Constant multiplier. It's the most important part, so you know what those two things are. That's all I'm going to spend time on for the review, because I have to go on to the next unit. But if you have any questions that you want me to go over one-on-one with you, I'll tell you how to do that at the end of this video, and I'm more than happy to do that for you, okay? But I got to move on before I get cut off. So without further ado, the emission that I signed for you guys this week is called Constant Rates of Change, which we started before the break, but we're going to kind of go a little more in depth with it, all right? There's 21 questions. You have until Friday, or Friday, I believe, to get all of these done. So here's kind of the idea behind what we're going to be doing in this mission. Constant rates of change. So the rates of change, like I said, that's the same as our multiplier, right? Our multiplier is the rate of change. So with that being said, Brand is driving at a constant speed, shown on this graph. How far has he traveled after 15 seconds? Let's look. 15 seconds would be here. How far did he travel? 75 meters. 75 meters in the first 15 seconds. So these first 3 questions, you just have to read the graph and figure it out that way. No math involved at all. These next 3 are a little more complicated. It involves a little equation. You got to put numbers in, right? So Joe runs a banquet hall. The equation R equals 3T represents the relationship between the number of people that can be seated and the number of tables. If there are 5 tables, how many people can be seated? So you put 5 in for T. 3 times 5 is 15. You could have 15 people seated if there was 5 tables, right? That's all you got to do. Do that same thing for these 2 questions. Just put a number in for one of either T or H, whatever it says. These graphs, you also have to calculate rate of change, but you can do that just by looking at the graph, right? So for example, let's do this one together. The graph shows data about a female marathon runner. What is her speed? Well, after 2 hours, she ran 5 kilometers. After 4, she raved 10. So she's moving every 2 hours, 5 kilometers. So how far is she moving every hour? Well, 5 divided by 2 is 2.5. Every 1 hour, she's moving 2.5 kilometers. So that's our answer right there. It's a constant rate of change because the line is straight. It's not going up on a curve or down on a curve, right? So we know it's constant. Do that same thing for these other 2 questions. Look at the graphs, figure out what the rate of change is. That's all you got to do. These next 3 are a little more complicated. If you remember, I have this page that I gave to you, but I'm going to post it anyways. Rate of change is the same as rise over run. What's rise? Rise is the change in height. So in this example, it starts at 6, it goes down to 0. What's the change in height? It's -6, right? Over run, run is the change in starting point and end point. So in this example, it starts at 0, goes to 4. It goes over 4. So -6 is the rise, over 4 is the run. So -6 over 4 would be the rate of change, right? Because all you got to do is put rise over the run. That's it. So let's do one more together. In this example, what's the rise? Well, it goes up 5 and over 2. Rise goes on top, so you put 5 on top, run on the bottom, over 2. So the rate of change is 5 over 2. The rate of change, when we get more complicated, is, like I said, is the same thing as your multiplier, right? That's what's changing. The rate of change is your multiplier. So try this last one out by yourself together, or by yourself, not together. These ones here, it's asking you to do the same things, but instead of looking at graphs, you're just kind of looking at a table of values, right? So Eric earns $11.25 per hour working part-time. Which table of values matches the description of this linear relation? So if he doesn't work any hours, does he make any money? No, he doesn't. If he works 1 hour, he makes $11.25. If he works 2 hours, he makes $22.50. That's right? That's just the table of values that matches. $11.25 is the multiplier. Per hour is what your time's going to by. There's no constant for this one, right? Just do your best to get through this mission. I only have 2 more minutes left on this video, so I'm going to end with this, alright? If you go to Google Classroom right now, you'll see under our class code, there's a Meet link. I want you, if you ever have any questions at all, to send me an email, and what we can do is set up a little video conference on this link where we can talk to each other face to face. I can answer any questions you might have. I can go over concepts like what's a multiplier, what's a constant, what's a rate of change, what those things mean in case you forget. We can set up a time. Like, hey, Mr. Boyle, can we talk for half an hour at 2 o'clock today about the mission you assigned us this week? Absolutely, we can. So we click this link, set up a call, and we could talk face to face. That's one way we could stay connected. So if you ever want to do something like that, just send me an email. We'll set up a time, and we can get that video conference going where I can talk to you one-on-one and we can get some questions answered. All right? I'm going to post these 2 documents in Google Classroom as well. This y equals mx plus b document and this slope document, rate of change, to help you out. And I'm going to post this video attached as well. So to reiterate, multiplier is what changes. Constant stays the same. Rate of change is rise over run. Change in the y-axis, or the height, versus change in the x-axis, or the starting and end points. Go through the modules, do the best you can. If you don't know what you're doing, don't worry about it. Try your best, and it will tell me what I have to go over more in the next video I post. Please ask me if you have any questions. And like I said, we can set up those video conferences if you want to go one-on-one and talk about stuff. Please, please, please try to get this done the best you can. And please, please, please come to me with any questions, concerns you might have, all right? I'm here to help any way that I can. This is weird for all of us. Yeah, like I said, please, please, please come with any questions. This is weird for all of us. We're going to try to do our best. I'll post again a couple updates in a few days, all right? Cheers, good luck, and let me know if you have any questions.